This is video number 1 on section 7.3, double integrals over general regions. Now, in the last videos we looked at Fubini's theorem, which talked about how to integrate over rectangles. The problem is not all regions in R2 are nice rectangles. So in this case we're going to look at regions that are a little more complicated. Now, I'm going to look at definition 204 and theorem 206 simultaneously. We're going to look at what we call a type 1 region. Now, what is a type 1 region? That's a region R at the xy plane where the x's are bounded between a and b and the y's are bounded between two functions of x. So all of the points we have here in this region R, these are the points in the xy plane where the x's are between a and b and the y's are between g1 of x and g2 of x. And this is called a type 1 region. And if we want to integrate over a type 1 region, so in this case R is our type 1 region, so we integrate fxy dA. Here we set this up as a double integral, and similar to Fubini's theorem, we're going to integrate with respect to each variable separately. Here we're going to start integrating with respect to y first. And our y limits of integration are g1 of x to g2 of x, because our y's are stuck between g1 of x and g2 of x. So we integrate this with respect to y. And then after we do that, and it's a definite integral, so we'll evaluate our expression at g2 of x, at g1 of x, and we'll subtract. And then we'll just have a function of x. And then we'll integrate from a to b of our function of x dx. And that's how we handle a type 1 region. Now, how do we handle a type 2 region? Well, first of all, what is a type 2 region? A type 2 region is a region in the xy plane where the y's are bounded between c and d. So our y's are bounded here, and our x's are bounded by functions of y. So here we have this function here of y. X is h1 of y, and over here x is h2 of y. So the x's are bounded between two functions of y, and the y's are bounded between two constants. This is a type 2 region. And so here when we integrate over our type 2 region, fxy dA, so the first thing we do is we integrate with respect to y. So we have fxy, we integrate with respect to x. That was a mistake. We integrate with respect to x, and so we have fxy dx dy, and then our x limits of integration go from h1y to h2y. So we integrate with respect to x first, and then we have, after we substitute and subtract, now we have a function of just y. And so we integrate from c to d of our function of y dy. And that's how we integrate over a type 2 region. Some regions are both type 1 and type 2. A circle, for example, if you look at the unit circle, that's both a type 1 region and a type 2 region. Now, according to these two theorems, theorem 206 and theorem 207, it doesn't matter how you integrate it. You'll get the same answer, and that's true. However, it may not be the case that both integrals have equal difficulty. So at some point in time, you might be looking at a region strategically to see if you want to set it up as a type 1 or a type 2, depending on which way it's easier to calculate the antiderivatives. And so in the subsequent videos, we'll actually look at examples of integrating our function over type 1 and type 2 regions.